First question. When a closed coil helical spring is subjected to an axial compressive load, the material will be subjected to option A, shear stress, option B, axial compressive stress, option B, bending stress, option D, tensile stress. And the answer is option A, shear stress. When a closed coil helical spring is subjected to an axial compressive load, the material will be subjected to shear stress. Next question. The polar moment of inertia of a circular section of diameter d is option A, pi d raised to 4 by 64, option B, pi d cubed by 32, option C, pi d raised to 4 by 32, and option D, pi d cubed by 64. The polar moment of inertia of a circular section of diameter d is pi d raised to 4 by 32. How can we find the polar moment of inertia? What is the equation of polar moment of inertia? Polar moment of inertia is the moment of inertia about polar axis. And the equation for polar moment of inertia, J, is equal to Ix plus Iy. That is the moment of inertia about x-axis plus moment of inertia about y-axis. So for a circular section, polar moment of inertia is pi d raised to 4 by 64 plus pi d raised to 4 by 64, which is equal to pi d raised to 4 by 32. So polar moment of inertia of a circular section is Ix plus Iy, which is equal to pi d raised to 4 by 32. Option C is the answer. Next question. The ratio of stress to strain is option A, elasticity, option B, modulus of elasticity, option C, bulk modulus, and option D, Poisson's ratio. And we know that the ratio of stress to strain is called modulus of elasticity. Option B is the answer. Next question. Pure bending is that bending where option A, shear stress is maximum, option B, bending stress is maximum, option C, shear stress is nil, and option D, bending stress is nil. Pure bending is that bending where shear stress is 0. In pure bending, only bending moment is there. It means there is no shear stress. So option C is the answer. We can calculate bending stress sigma is equal to 32m divided by pi d cube, where m is the bending moment and capital D is the diameter of the shaft. So sigma is equal to 32m divided by pi d cube. Pure bending is that bending where shear stress is nil. Option C is the answer. Next question. If a cantilever beam carries a uniformly varying load, 0 intensity at the free end, W per unit length at the fixed end, then the shape of the bending moment diagram is option A, cubic parabola, option B, quadratic parabola, option C, straight line, and option D, triangle. And the answer is option A, cubic parabola. If a cantilever beam carries a uniformly varying load of 0 intensity at the free end, W per unit length at the fixed end, then the shape of the bending moment diagram is cubic parabola. What will be the shape of the shear force diagram? It will be parabolic in nature. Sixth question. In an overhanging beam, the point where the bending moment changes its sign is option A, maximum shear force point, option B, point of contraflexure, option C, support point, and option D, none of these. And the answer is option B, point of contraflexure. In an overhanging beam, the point where the bending moment changes its sign is called point of contraflexure. Next question. In a cantilever of length L carrying a gradually varying load, 0 at the free end to W per unit run at the fixed end, the maximum bending moment is option A, WL square by 8, option B, WL square by 2, option C, WL square by 4, and option D, WL square by 6. And the answer is option D, WL square by 6. In a cantilever of length L carrying a gradually varying load, 0 at the free end and W per unit run at the fixed end, the maximum bending moment is WL square by 6. And this maximum bending moment will be at the fixed support. Option D is the answer, WL square by 6. Next question. A ratio of moment carrying capacity of a circular beam of diameter d and square beam of size d is option A pi by 4, option B 3 pi by 8, option C pi by 3 and option D 3 pi by 16. And the answer is option D 3 pi by 16. The ratio of moment carrying capacity of a circular beam of diameter d and square beam of size d is 3 pi by 16. Next question. In a beam, the neutral plane. Option A may be its center. Option B passing through the center of gravity of the area of cross-section. Option C does not change during deformation. Option D none of these. And the answer is option C does not change during deformation. In a beam, the neutral plane does not change during deformation. Option C is the answer. Next question. When shear force at a point is 0, then bending moment at that point will be option A 0, option B minimum, option C infinity and option D maximum. And the answer is option D maximum. When shear force at a point is 0, the bending moment at that point will be maximum. Next question. The ratio of equivalent length to actual length of a column having both ends hinged is option A 1:1, option B 2:1, option C 1:2 and option D 1:√2. And the answer is option A 1:1. The ratio of equivalent length to actual length of a column having both ends hinged is 1:1. If both ends hinged, the effective length will be L. If one end fixed and the other end free, the effective length will be 2L. If both ends fixed, the effective length will be L by 2. If one end fixed and the other end hinged, the effective length will be L by √2. Next question. A column is a option A horizontal tie, option B vertical strut, option C vertical tie and option D horizontal strut. A column is a vertical strut. Option B is the answer. Next question. Due to the torque in a shaft, every cross section of it is subjected to option A tensile stress, option B compressive stress, option C shear stress and option D bending stress. And the answer is option C shear stress. Due to torque in a shaft, every cross section of it is subjected to shear stress. 14th question. The slope at both ends of a fixed beam will be option A 0, option B maximum, option C minimum, option D average. And the answer is option A 0. The slope at the ends of a fixed beam will be 0 because both ends are fixed, so there will not be any slope there. Last question. In a simply supported beam, the point where the maximum bending moment occurs is at option A support point, option B midpoint, option C the point where shear force is 0 and option D end point. And the answer is option C, the point where shear force is 0. In a simply supported beam, the point where the maximum bending moment occurs at the point where shear force is 0. If you felt the video useful and informative, please press the like button, share the video and subscribe the channel. If you want videos of special topics, please write below in the comment box and give me your valuable suggestion. Watch all other uploaded videos to ensure top rank in all the competitive exams.